Yeah, my decision on reality.
3 coplanar points, and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It really
totally
is.
agree.
Level.
It really
totally
is.
agree.
Level. Level.
And bam, there's the radius of the Earth.
Well, I'm telling you what reality is, and
I'm not talking about reality at all.
yeah, obviously. First, like contention that you have of this group of people.
I'll live debate, whatever you want to call it. But,
so do you know any of your maths and your geometry and all of that sort of stuff for the model?
Yeah,
right.
Yeah, like.
So are you happy with 4 inches at half a mile with Sean? I mean, I know you don't know Sean.
I'd have to figure it out. I'm pretty sure I could figure it out, but it's not.
Don't you know what anarchy is? You wear my love, you wear my flag. I'll slice your face off. You got something wrong with me? No.
8 inches would be the drop from
the horizontal.
From the horizontal. Well, from like eye level, or actually be at your feet, but.
Yeah, from the horizontal out from your feet, you think there would be a drop.
That's the drop, but that's not how you calculate.
That's just the water level, though, right? The drop of the water level, not the actual level. Because when you use a tool, like an auto level or a theodolite, that establishes a horizontal plane of reference, right? So that doesn't drop. That's where you measure the drop from your supposed water level drop, right? It's from that horizontal.
It's in the geometry. If you're looking straight out, and if you're on a sphere, then that's how much the sphere drops away from you, and it's an exponential function.
When you're talking about a geometry, though, you were talking about like triangular geometry with one of the sides of a triangle being a curved surface.
Chord length and arc length can be calculated differently. So, the difference between chord length and arc length, I certainly don't know off the top of my head.
Where's the difference between the chord and the arc length? I mean, are you presupposing that the chord would be a horizontal, or are you presupposing the arc is the horizontal? I mean, which one are you going with there?
Okay, if you draw a circle.
Draw a circle? Why?
You're asking about the difference for length. Right?
No, I'm talking about the different, not in actual geometry. I'm talking about if you're comparing it to the geometry of the drop of a level. Like, you're not talking about a level on a circle, because that'd be ridiculous, right? Level is a real life term.
I'm not talking about level at all.
Yeah, you were.
It's an autonomous collective. This is funny.
Sorry?
Alright, a Monty Python.
Yeah. Well, I'm telling you what reality is, and
I'm not talking about reality at all.
Obviously.
Could you explain that for me? Because I've seen Monty Python and I can't see the simile. What bit of Monty Python do you find similar to listening to us guys?
The accent.
Yeah, it's definitely the accent. There's a scene out of the Holy Grail where the mob finds a witch, and then they kind of try to explain how you find out if it's a witch.
Yeah.
I don't know. It's just the way the interaction. One guy being all logical.
Yeah,
But
but you understand
it's
that you understand that
the
Monty
accent.
Python is satirical, right? It's sarcasm, satire.
Yeah, of course.
Do you think that we're talking in satire or satirical language, or do you think that we're being straight talking and like literally straight, pardon the pun?
It's just the interaction, the trying to
Yeah, it's
logically
not satire.
follow.
We're not talking
Oh.
satirically, my friend.
Yeah, I know that.
So it was just an insult then, right? A slur.
Not at all.
Well, there isn't an obvious comparison between Monty Python and what we talk about, unless you're just being insulting.
I'm just explaining when I first tuned into this channel, and I was listening to something, how it reminded me of Monty Python.
Right. Okay, I'm done.
Just the logicalness of the way we're talking.
Anyway, I'm not insulted. I'm
Yeah, I
not
was.
insulted. Monty Python's freaking awesome.
Yeah, I think Monty Python.
Life of Brian's my favourite though.
I think you might be missing a bit of the humour. So, when we're talking about a level and the horizontal and the drop from the horizontal, like you said at the beginning, what was it that you were saying that is the drop from the horizontal at 8 inches per mile? I mean...
Okay, 8 inches per mile describes a parabola, right? But it approximates drop over...
No, 8 inches per mile is Sean's slope. Because that would be 4 inches at the half mile, wouldn't it?
Yeah, but that's...
Shout out Sean Hawkins.
I'm trying to say...
Slope Earth.
It's Sean Hawkins, whoever he is. If he's
Shout out
using 8
Retracted.
inches... If he's using 8 inches per mile, that's not correct.
He had 4 inches at the centre point.
Right, but it's not the right...
Can you say he's wrong? Right? He is definitely wrong, isn't he?
I am saying he's wrong.
Yeah.
Are you going to contrast with the 7.98 inches per mile squared, or are you saying something else?
No, I'm not contrasting that. I'm just saying if you're trying to find the difference between chord length and arc length, then 8 inches per mile is not the right way to do it.
What, is it a chord? No. We're just on about the amount of drop from the horizontal over a mile.
I was going to say he's not trying to find out the difference in the chord length compared to the arc length.
Yeah, he seems to have got confused with his geometry. Like he's heard geometry and he's automatically gone to chords and arcs and tangents and all of that stuff. He forgot about that we're dealing in reality.
Oh, that's what your water level supposedly with everything works. I don't mean to say supposedly as if it's not going to work. I'm just saying the test hasn't been done, but what you would be looking for would be the difference in the middle between the chord length and the arc length.
Well, the length of the chord and the length. And I think you're talking about a sagittar, aren't you? I mean, like, are you surely not talking about the length of the chord and the length of the arc? I mean, that'd be a bit stupid, wouldn't it? Why would you want to do that?
Not the length. Well, the arc length would be any bit longer than.
Yeah, but why are you talking about the chord and the arc when we're talking about a water level test that checks the centre? What's the centre got to do with the arc and the chord? What would be the point in that? I mean, obviously we're not checking a distance measurement because the distance measurement would be the same, wouldn't it?
I'm not talking about distance measurement.
Good. So we're talking about the drop from the horizontal.
So a sagittar, all right. Is that where a line intersects a circle in 2 points?
I don't know. Like, that sounds like a chord to me. But I mean, it could be the diameter. The diameter intersects the circle at 2 points, doesn't it? Right?
That's why I'm trying to go back to just something basic, like if you.
Yeah,
you draw.
But you keep going back to geometry that you obviously don't understand when we are talking about reality and the supposed drop of water level from the horizontal? Why do you keep talking about circles? What's wrong with you?
I'd actually have to, draw it out for you. Maybe I'll post some. But
would you start with a circle?
first, I would start with a circle to illustrate the concept.
You'd start with the concept drawing.
Oh, that's what we're doing. We're just.
No, we're showing you a practical test that involving water levels. It's practical tools to show you that they would all lie on the same straight line, thus proving level is horizontal. Horizontal is a known straight line, it being perpendicular to vertical. Now, that's geometry for you. Right. Why do you keep wanting to inject a circle? How do you define the circle, and where are you going to place it on the horizontal? Why are you doing that?
So you just did it where you talked about vertical, horizontal being perpendicular.
Yes.
That's just the concept of it, right?
What concept? That's two straight lines.
That's more like definition.
In like a plus sign.
And you were asking about whether 4 inches sounded correct. Well, I'm telling you that 4 inches does not sound correct, because you said that the Sean guy was using the 8 inches per mile, which is the wrong way to figure that out. You're trying to figure out how much difference in the water level in the middle for your test you'd expect to see if you're measuring this on a circle. Right.
Well, you see,
that's
what you're not understanding, because I don't know how much of the game you've ever been into, and you said this is new for you and all of that, right? But
he's not listening.
It's all right, Neil. I mean, if once you realise that this is reality, right, and you don't even understand what 8 inches per mile is, do you? And what the problems is with that, just that very statement.
Oh, it's just one way of figuring out drop from level.
Yeah, but you do realise, like, geometrically, 8 inches per mile is a slope. Do you think you live on a sloped earth? Because Sean does. I mean, like, you've just tried to sort of defend it and the calculations or whatever, but not actually realised that he's talking about a slope. Because that's the only way you could get 4 inches over half a mile and 8 inches over a mile, is if the line was a straight line. Sorry, I've got to take this phone call, but this is me, surveyors probably.
It's also miles squared, which means it's not a linear function.
I don't know what it's about to total station accuracies, but
yeah. It was just the accuracy of your all your different levels. You know, the optical, laser, over distance. You know, like what? So the optical levels that you've got. Which is the best one that you could see maximum distance, and what sort of accuracy would you be looking at? You know, to keep the accuracy good, what would be the maximum distance of them?
This is all very my opinion, if you like.
Yeah.
I think you struggle to see over 50 meters accurately. Probably stick it to sort of 30 or 40 meters max.
That's with an optical.
That's with an optical, yeah.
Could you get better with laser?
What sort of work is it you're doing? What are you looking?
We're just after trying to do a test to see what is the longest length you can get, keeping a level.
Well, the optical level is going to be more accurate than a laser level.
Would it?
Yeah, definitely. But it all depends. Laser levels are generally used for groundworks and making sure you're within sort of 5 or 10 mil of groundworks. Optical levels are more to the precise millimeter, if you like, but that all comes down to how the actual user uses the kit and how the person rocks the staff, and there's all sorts of bits that can influence the readings, and so it all depends on what you're doing, really.
Well, I've seen it on your site as well. I can't quite get to it at the minute. You have like a big site, is it? Survey instruments, what do they call them? The Datum Electronics Theodolites. I mean, they look like pretty effective bits of kit. What sort of distance could you get on from them?
So what are you looking at? On the website, which part?
The Datum Theodolite.
All right. So theodolite is just an angle that measures angles. That doesn't measure distances.
Yeah, okay. I don't want to measure distances. I just want to like an accuracy range that you can keep the horizontal level. A
theodolite just tells you the angle. So you point it at something, and you make sure you're in line with it, and you turn the angle. So that's all that's going to tell you, really.
But it does it not set a horizontal? Could you not, or would you?
You can, yeah, but it's just not ideal because it's no more accurate than. Well, I'd probably say it's slightly less accurate than a dumper level, because as you're turning the theodolite, it can, as you're looking through, it can just slightly knock it. So I would if you were wanting angles, use a theodolite. If you're wanting levels, use a datum at a level. So
the best 32 times scope on a
32 times is the magnifier at the lens you're looking through.
Right, but so that would be like the one that could see the furthest.
Yes.
Right.
Yeah.
And it's just one line of sight that we're after, really. So you really think that would be the best we could do?
You can move between. I mean, how experienced are you with like leveling?
Oh yeah. I can set the level up and move it around, but in order to keep ideally one straight line as straight as we can, as level as we can.
Right. Okay. So I would stick to using a dumper level for levels and a theodolite for angles. That's what my personal opinion.
Okay.
But a 32 magnifier is the best lens you can get, really, from optical levels.
Okay. So, and you say about 50 meters would be.
I wouldn't. Yeah. I'm going. I used to work on sites, and used to use dumper levels quite regular. I wouldn't be asking a guy to walk more than 50 meters away from me. I would say you sort of that personal pressure. You can go to university, and I actually or college, and they might say, yeah, you can go further, or it's better to go further. I personally stuck to about 40 meters maximum. Just purely, I find it more easy to read, more accurate, and then if I need to go further, I'd just do another setup.
Yeah.
So I'd half the 50 meters to 25. But that's not to say that's right or wrong. That's just what I found easier.
Okay, so would you say that a water level at that length would be more accurate then? If we was to make a water level like a hose pipe or whatever at 100 meters, would that be more accurate than the optical level?
Do you mean so you're going to create a 100-meter pipe type thing?
Yeah. If we make it like a water level.
I've never done. Yeah, I know what you're saying, but I've never done that before, so I couldn't sort of tell you that'd be more accurate. I mean, water don't lie, does it? But I don't know how you'd do it over 100 meters.
We just put the vials in the end of it and have your water level. I mean, would you trust the water level within that?
It's not really for me to say. I couldn't. I've never done it before, so I couldn't give you a qualified answer on that. To be honest with you.
Okay. Cool.
Yeah.
All right. Brilliant. Thanks a lot.
All right. Thank you.
Cheers. Ta-ra. Hey up.
Gotta say you're blowing my mind right now.
You twat. How do we know the Earth is not flat?
We don't. It's flat.
That was that.
your understanding of the world in which you live, then of course the world looks flat. The world looks flat. The world looks flat.
Neil,
Bitch. You twat.
I gotta say, you're totally blowing my mind right now.
That's what I do. 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 What I do.
But I don't have much patience for anyone who denies that this challenge is real. We don't have time for a meeting of the Flat Earth Society. Flat Earth Society.
My friends, these people are so out of touch with science. You don't need to be a scientist to know that the Earth is round.
They must have been founding members of the Flat Earth Society. They would not have believed that the world was round.
Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put in a teapot, it becomes the teapot. Now water can flow or it can crash.